Rewind yourself to 66 million years back and imagine sunrise on the last day of the Mesozoic era. Beams of sunlight sweep through the moors and coniferous woodlands along the coast of what is now known as Mexico's Yucatan Peninsula. The Gulf of Mexico and its seas are still teeming with life, but something terrible is about to happen in the dino world. This video is brought to you by Answerly, a question answers platform that pays you for adding high-quality answers to different questions. The answers are rewarded in Answerly tokens, which they can easily convert into dollars or any other cryptocurrency by using one of the exchanges mentioned in the description. As the world of dinosaurs and giant insects squawks and hums to life, a mountainous asteroid is racing towards Earth at an insane speed of about 40,000 miles an hour. A fireball that appears far greater and more vivid than the sun bursts through the skies for a few fleeting seconds. A moment later, the asteroid slams into Earth, with a volcanic yield rated at over 100 trillion tons of TNT. The asteroid enters Earth's crust to a base of several miles, digging a crater more than 115 miles, evaporating thousands of cubic miles of rock. The event sets off a series of global calamities that clear out 80% of life on Earth. Yep, that's how our dinos died. The chances are high that you might have read this apocalyptic tale's distorted version in a book or magazine already. Since Nobel Prize-winning physicist Luis Walter Alvarez first published the asteroid impact theory in 1980, many such accounts have been published. In the 1990s, the identification of the Chicxulub crater in the Gulf of Mexico gave scientists an accurate answer to many unanswered questions. But precisely how the fallout killed off so much life on Earth has remained an intriguing mystery. A team of British investigators operating an offshore drilling platform in the Gulf of Mexico took the first ever core samples from the peak ring of the Chicxulub crater. This ring is where the Earth rebounded in the following impact, and the ridge formed a large orbicular structure within the crater walls. By examining its topsy-turvy geology, researchers hope to learn better the dark forces unleashed that bleak day. Let's review what we know so far. Here is how the events folded on that ominous day. If you were close by the impact, say 1,000 kilometers, you would be immediately, or within a few seconds, annihilated by the fireball. A burst of thermal radiation would have barbecued 9 seconds after impact an onlooker at that distance. Trees, grass and bushes would have immediately burst into flame. Anyone present on the scene would have experienced on the spot third-degree burns over the entire body. A flood would then follow fire. The collision would have kicked up an extraordinary tsunami up to 1,000 feet high at the very least. It is a calculation made keeping the local topography in mind. A 10.1 earthquake on the Richter scale would have been more forceful than anything ever measured or endured by the human race. Roughly speaking, a seismic event of this extent would be the equivalent of all the world's shakes for the past 160 years going off together. 8 minutes after the impact, ejecta would begin to spill down, extinguishing the blazing landscapes beneath a cover of hot sand and ash. Closer to the impact zone, thousands of feet of rubble would hide this area beneath. About 45 minutes later, a gust of wind would rip through the area at 600 miles an hour, dispersing debris and wrecking anything that might still be persisting. The sound of the blast would arrive at the same time. Researchers have estimated a 105 decibel roar at the very least, as deafening as a jet making a low-pass flyover. Out of range, the immediate consequences of the explosion, an onlooker would marvel at the display of darkening skies, and an apocalyptic spectacle of shooting stars. All of this dramatic theme created by the impact of debris pouring back on Earth. It would not have been like the regular shooting stars or meteors. Meteors burn up at a tremendous speed and get grilling. These would have been re-entering the atmosphere at lower altitudes, travelling slower and releasing infrared radiation. A red glow would have been their distinctive feature. For the first few hours, they would have been close to total darkness. But shortly after that, the sky would begin to lighten. The following weeks, months, and even years were presumably between twilight and a very overcast day. But it wasn't the asteroid itself that killed the dinos. While most articles and descriptions concentrate on the dramatic violence of those first few moments to weeks after the impact, that wasn't what killed the dinos. Instead, the long-term environmental effects eventually wiped out most dinosaurs and much of the remainder of life on Earth. For one, the overall dimness caused by the dust might have reduced photosynthesis dramatically. The smoke and ash would have taken some moons to wash out of the air, and when it did, the rain would have fallen as an acidic shower. Massive fires would have produced vast volumes of toxins that briefly destroyed the planet's shielding ozone layer. Then there was the carbon footprint of the impact itself, which released massive volumes of carbon gases. A careful estimate tells us that 10,000 billion tonnes of carbon dioxide, 100 billion tonnes of carbon monoxide, and another 100 billion tonnes of methane in one fell fall. Researchers believe that, in effect, the eventual outcome of the asteroid impact was a powerful nuclear winter, followed by dramatic global warming. These changes then led to the eventual wiping out of the magnificent creatures. Did anything survive this impact? Well, plants were less affected than animals, because their seeds and pollen could withstand severe sessions for longer. After the dino extinction, flowering plants ruled Earth, advancing a process that had started in the Cretaceous and remained to do so today. However, all the land animals weighing over 25 kilograms died out. All of the non-bird dinosaurs died out, but dinosaurs persevered as birds. Some species of bird did go extinct, but the forefathers that led to modern birds survived. A couple of lineages of enormous birds, predatory and herbivorous, weren't around for very long and also went extinct. It was only around 15 million years ago, after the non-bird dinosaurs disappeared, during the Oligocene epoch, that we started to get giant mammals. This is when rhino-sized animals begin to reappear. But up until that point, it was a world filled with small animals, especially compared to the dinosaurs that came before them. You can even paint a vivid picture of the events of that fateful day. Using an impact calculator, designed and developed by a team of geophysicists from Purdue University and Imperial College London, you can enter a few key details, such as the asteroid's size and speed. One can plug in different distances from the impact point to see how the outcomes change over range. To this date, dinosaurs remain the largest land animals ever to have existed, and yet their size was of no avail in the face of a fiery asteroid. 66 million years have passed since an asteroid led to a mass extinction event. Will such an event ever happen again? After hearing the sad tale of dinos, it is hard to say no with conviction. Have we made any real progress as to thwarting a giant rock that has the potential to set pretty much everything on fire? Guess we will only know when a fireball comes our way. This video is brought to you by Answerly, a stellar blockchain QA platform that pays you to learn. If you loved what you just watched, make sure to smash the like button and subscribe to this channel. To learn more about Answerly and Answerly tokens, check out the links in the description.